Alright, so today we're going to talk about open root V-groove welds using the GTA process. This is basically going to cover what you're going to be doing in class and how you're going to be doing it as well. So please be sure that you do take notes as I go through this. That way, when you are out in our lab, you could just pull out those notes and look up trivial things such as what temperature should I be using, what rod should I be using for this pass, etc. Things like that. So let's get started here. And so before we start welding, we have to prepare our metal. Before, when you're working with T-joints, you're not going to be using that material anymore. You're going to be using 3/8 thick material in order to perform these groove welds. And for that, you're going to have to learn how to use a track burner. Now, I'm not going to teach you how to use that track burner today. I can't really do it as I'm over the internet as I'm doing right now. And so what I'm going to do, I'm going to take you guys out there as a class and I'll show you exactly how to use that track burner. And so the main thing that I want you to know for now is the size and dimensions of the plates that you are going to be cutting. And so here are our dimensions. You're going to cut two 6-inch by 2.5-inch beveled plates. And so what I'm referring to are these here. So we have one here and then we have another one there. So we're going to cut two of them. They're going to be 6 inches long, 2.5 inches wide. After you cut those out, you're going to clean at least 1/2 inch on the front and back side of these coupons. And so this is a little bit of a clearer picture as to how I want that to look like. And so as you can see, this is the back end of the coupon. You're going to clean about 1/2 inch along that bevel side. And then on the front end of the coupon, you're going to clean about 1/2 inch on the top as well. After you do that, you are still going to clean up that bevel itself as well. And so that's why we see nothing but nice, clean, shiny metal along that side. You do not have to clean up the whole surface of that bevel plate. You could do that. It's not going to hurt anything. However, you are going to be wasting a lot of time doing that because there's just no need for us to do that. So just 1/2 inch on the front and the back, and also clean up that bevel. Do not put a landing on this like you would if you're welding with stick. So no landing, no root face on this. Just keep this edge really nice and sharp. And as you're cleaning this up, make sure that you try to keep your corners as sharp as you can as well. When you are cleaning this up, do not use a wire wheel, which is this wheel here. And also do not use a tiger disc, otherwise known as a flap disc. The reason I don't want you to use a flap disc is because it will easily damage these edges that I've asked to keep nice and sharp. I don't know if you could see it from your screen. However, if you download this PowerPoint from Blackboard, you will be able to see it. So here we could see that we have a really nice sharp edge. However, taking a look at this opposite end, it's kind of rounded out. And that's because a flap disc was used, or the operator of the grinder perhaps wasn't very cautious of what they were doing. But I do prefer that you use a grinding disc as well. The size of the grinding disc doesn't really matter. I would just go ahead and use a 1/4 inch and save your 1/8 for other applications. And so when you do cut your two coupons, now we're going to fit up these coupons. And so what you're going to do is that you're going to put them in your table inside of your booth upside down, meaning that the groove side is facing down, and you're going to get your 532 spacer, which I will give you. All you have to do is ask me for it if you don't have one, and you're going to use that spacer to space these two pieces of plate apart. And so what I'm going to end up giving you is a welding rod for stick, and that welding rod is 532 thick. And so you're going to remove the flux from it, and then you're going to bend that rod into a U or a V shape, very similar to how we see on this picture. And then you're going to insert it in between the two plates. You're going to kind of push those two plates up against each other so that we have a real nice tight gap. And then this gap should be 5/32 because our rod that's in between them is 5/32. And so that's what we're going to refer to as our root opening. Once you space those inside of your booth, we're going to put some tacks on there. The way that you're going to put these tacks is very specific. If you're not careful, you could easily ruin your piece of plate here. So please be careful as you're doing this. You're going to set your control box to 12 to 15, which is roughly about 80 amps. Now, this control box is for room 111. If your classroom is in room 112, all you simply have to do is get whatever amperage I give you, and you're going to divide it in half. So if you're in room 112, you're going to set your control box to 40 because that's half of 80, and that's the temperature that you're going to be doing your tacking. If you're in room 111, this is what you're setting your control box to there. So for our tacks, you are going to need a 1/8 filler rod. Make sure it's a nice clean filler rod. Now at this point, we still have that spacer in between both of our plates. And so pick the side that's closest to you in order for you to put that tack. The way that you're going to do that is that you're going to strike your arc on one side of those plates on the very corner. For example, here, you're going to strike your arc. You're going to let that part heat up just a little bit. Deposit a little bit of metal on this side. Once you do that, go over to the other side, heat it up, deposit a little bit more metal on that side. And then after that, you're going to basically carry your tungsten and your rod with you. If this is my tungsten and this is my rod, you're going to carry them like this to where they're always touching each other, and you're pushing metal in. And what that's going to create a bridge tack. It is a little hard to show you just by hand motions. And so if you do have trouble with this, by all means come get me. However, I at least want you to try it on your own at least once. At least once. That way you know what you're getting yourself into. Not only that, but when I explain it to you, it's going to make a lot more sense to you because you've already tried it. And also, of course, if you do try it, and even if it looks good, come show me, just so that we're on the same page and we make sure that your tacks are the way that they're supposed to be. So once you complete that side, you're going to notice that the spacer that you still have in between these two plates, it's going to tighten up. And so remove that spacer, confirm your measurements after that. Make sure, for example, that one of your plates didn't go up. If it goes up and one plate ends up higher than the other, that's what we call high-low. So check for high-low, make sure they're still leveled. Make sure that your gap is also fairly the same. For example, if you tack it on that side, on this side here, what's going to happen is that your plates are going to want to do this. It's going to open up on the opposite, and it's going to tighten up on the side that you tacked it. And so, again, check those measurements as well. Make sure that your gap is still fairly even from one side as opposed to the other. And if for that, you could simply just either push the plates together a little bit more with your hands, or just pull it apart if you need to do that. And even if they have high-low, again, just manipulate those plates to where we have a nice flat, even surface. If you want to confirm your measurements with me, just to make sure that everything is okay, again, come get me, come show me, and I'll help you out with that. So now that we've placed both of our tacks, the very first position that you're going to be working on is the 1G position. In order to position for that position, put that piece of plate about waist high for that 1G. And then you're going to set your control box to about the same. So whatever it is that you did your tacks at, that's the same temperature that you're going to be running your root pass at. You're still going to be using a 1/8 filler rod. And then comes the fun part. Compared to everything that you've done before in this class, this is by far the hardest thing that you're going to do. Many people even think that this is harder than welding on pipe as well. And so you are going to get frustrated. It is going to take some time to learn. However, Don't frustrate yourself too much to the point to where you won't even ask for help. Uh, so again, just like on your tax, I do want you to try this out on your own initially. However, after you tried it out, come get me. That way I could go in there, I could show you, and you're gonna have a much better understanding of what we gotta have to do. But here are the basics when running the root pass. So let's take a look at this picture here first. Or actually, let's take a look at this top right hand picture. Before you start running your root pass, make sure that you could get that 1/8 rod and put it inside of your gap. So if you recall, we put a 532 gap in here, and so that gap is 532 is bigger than 1/8, and so you should have no problem putting that rod inside of that gap. If your 1/8 rod does not fit, it means you went wrong somewhere along your fit up. The reason I bring this up is because it is crucial that as you're doing this root pass that you are able to put that 1/8 rod inside of that root opening. If you can't, then your root pass just isn't going to come out well. And so make sure that you're able to do that. After you know that you're able to do that from start to finish, then put it in position, again, waist high. And the way that you're going to position this filler rod is by simply hovering it inside of that root opening. So this is something that you've never done before either. And everything else that you've done in the past, you've always had somewhere to lay that rod down. Here, you're not going to be able to do that. So it's more or less just hovering inside of this root opening. And as far as how high you have to have it, is that you need to have it inside of this groove, meaning that if we're looking below or on the back side of this beveled plate, I need to see that rod sticking out a little bit from that back end side. And so if you're looking at it from the front end, it should look something like this. Now, I do know that we're looking at two pieces of pipe here. However, it is the exact same thing. If we just pretend that we're looking at a flat surface here, this is how it needs to look like. Same thing on here. And once you have that rod there, you're going to strike your arc. Right, you are going to have to remove your rod from there. So you're going to strike your arc and then put your rod in position, which is this position here. And then you're simply just shuffling the cup, because this is very, very similar to T-joints. If you notice that groove that we're welding inside of, it's like this. And so that should look fairly familiar, because that's exactly how your 1F position looked like. And so we have to shuffle the cup. We can't walk the cup, because in order to walk it, we do need a flat surface. So you're shuffling the cup as you have that rod in there, and as long as you're keeping it in this position, then you should have no trouble filling in that gap and bridging from one bevel plate to the other. And as you're shuffling, you have to be making sure that you're tying in properly on both sides. So if that wasn't enough for you, the other thing that you have to make sure that you're doing is not only hovering that rod in there, but also you have to feed that rod in there as well. The second you stop feeding this rod, meaning pushing it up towards your tungsten, the second you stop doing that, you're going to get what's called a keyhole, which is basically just a big hole inside of this groove here, of this root opening. And so when that happens, it's going to be really hard to recover from that, because whatever metal you're carrying with you, right when that keyhole happened, you're going to have a lot of metal coming off from that back end. And we'll talk about what excessive penetration is here in a bit. But it's important that you're not only feeding that rod, but you're also keeping it on the correct position. And of course, you're shuffling that cup in there. Again, it's very hard to really show you through just a simple PowerPoint, but those are the basics, and that's what I want you to have in mind as you start trying this for the very first time. And so this is about more or less how your root pass is going to be looking as you're doing it. For one, take a look at the position of this rod. Notice, again, just like in the picture before, it's a little on the back end side. And also, it's always tied in to your puddle. This rod, the second that this rod separates, a keyhole forms, and that's when we get too much reinforcement on that back end side. And so you always have to make sure that you're feeding the rod in to where it never separates. Now, yes, it is going to look a bit dirty, a bit nasty in the beginning here along the top side. However, as you start getting better and better at it, notice our consistency also starts to improve. So it'll look a little bit more like this. Now, this was done just for demonstration purposes. However, when you weld and you want to stop welding, make sure that you remove the rod before you stop. Don't let that rod get stuck on there like they did on this picture. Now, if we flip your bevel plate over to the opposite side, it should look very similar to this. Notice how we have real nice consistent penetration on the back end side. This is what we call root reinforcement. Again, this is a piece of pipe. However, it should look exactly the same thing, the same way on a piece of bevel plate. Real nice consistent root reinforcement. And again, notice there's no high spots or anything like that on this. And so the maximum root reinforcement you could have as you're welding this is 1/8 of an inch. So when you do bring me your plate for me to look at or grade or whatever it may be, anytime you have spots that are over 1/8, I will be counting points off on that. So just keep that in mind. An easy way in which you could measure whether you're over 1/8 or not is just simply using your 1/8 filler rod that you've been using. Use that, put it side by side with your root, and that should tell you whether you're over 1/8 or not. If you do keyhole, like we talked about before, to where you're not feeding enough filler metal in there, what's going to happen is that you're going to have flat spots, and then when you maybe fed it in too much, you're going to have spots that are real high. And so next up, I want to show you what some of these defects might look like. And so here we can clearly see that this particular person kind of stayed in that same spot for way too long. Perhaps they sat there for a long time and they fed it in way too much. Here we have what's called cold wire. Cold wire happens when you're not feeding your rod in consistently. And so when we are feeding this rod during the root pass, you're not just pushing it, stopping, pushing it, stopping, you're consistently feeding it in. And so your rod never stops moving, but you're feeding it in at a very slow rate. If you accidentally push in that rod harshly, that's what happens here, is that you'll get cold wire. Also, besides this apparent spot here where there's excessive reinforcement, notice these other spots. See how it's a bit inconsistent? So you have good penetration, then it's flat, then penetration more, then it's flat. And so it's fairly inconsistent, as opposed to looking at our previous ones here, right? There's quite a bit of a difference there. And so this is what you're aiming for, is this consistency. Now, going back to this slide, when you do stop, because chances are you're not going to do this whole piece of bevel plate in one sitting. You are going to have to stop. So similar to your T-joints, where you had to do that little spot that was probably about an inch long, you will have to turn around and do that with your left hand. So just keep that in mind. So you will have one restart somewhere along that root pass. When you do this restart, the way that you're going to start back up again is that you're going to strike your arc somewhere along here. So if this is the edge of your weld, you strike your arc a little on the back side, maybe about a 1/4 inch back. You strike your arc, and then you start moving slowly forward until you get to the very edge. Once you get to the very edge, your rod should already be positioned. I don't want that rod touching the edge just yet, however. I want you to sit here with your tungsten until the edge gets cherry red hot, meaning that it's starting to turn molten. Once it's in that phase, that's when you insert your rod up against your edge here, and then you just start doing your normal routine as if you never stopped. And so that's the proper way to do a restart. If you don't do your restarts properly, you could have something like this happening. For example, here we could see that there's not any penetration, so chances are is that they didn't let their edge heat up hot enough to where when they did insert that rod, to where it would fuse properly. So be on the lookout for that. Other things to consider when you are doing your root pass is lack of fusion and lack of penetration. Lack of root penetration is when you don't get any metal on the back end side. So if your rod is positioned too high up against that bevel, remember we need to keep that rod a little bit below the bevel. So if your rod is out of position, that could easily happen. Or if you're not feeding the rod in enough, if you don't feed it enough, then there's not going to be any metal for you to have any penetration. And so always consistently feed that rod in. So that's what lack of root penetration. Lack of root fusion is something different. So if we're looking at this part of the root, we could see it's clearly tied in all along this top side. However, looking at the back, I could still see the bevel itself. And so we have lack of fusion all on this side here, not on the opposite side, just on this side. And so just know the difference between those two. And here's a little bit of a close-up shot of lack of root penetration in this case. There's no lack of fusion anywhere in here. This is just lack of root penetration. And so that's what your root pass is. It is going to take some time to get used to. Chances are the very first one you do, it's going to look fairly beat up, and that's normal. But again, don't give up on it. And also don't just throw this piece of plate away, because you still have to practice your hop pass, your fillers, and your cap, which we'll get to here in a bit. So no matter how bad your root looks like, I want you to keep going. Not only that, but once you're perhaps maybe on your third or second piece of bevel plate, I'll start showing you as to how you could repair something like lack of root penetration or lack of fusion as well. So we finished up our root pass. Looks really nice. Now we're going to start our hop pass. For your hop pass, you're going to set it about the same as you did on your root pass. You could turn it up just a little bit more if you wanted to, but not a whole lot. So it's going to be about the same as what you ran your root pass. You are going to switch filler rods. You're going to be using a 332 filler rod. You're still shuffling the cup because we're still not on a flat surface. And just like you did on your T-joints, you're going to ensure that you're getting proper fusion on each side of that bevel. So from the hop pass all the way to your very last filler, it's going to be fairly the same thing that you've been doing before, because now that you closed up your root opening, right? Now we're looking at a bevel which looks very similar to a T-joint. So treat it the same as you did on your T-joints. As you start putting these passes on there, make sure that you're just barely covering up the edge. Make sure you have good fusion against the wall. Make sure your hop pass is coming out flat. We don't want it concave, and we don't want it convex either. So it's more or less the same of what you've been doing. One thing that I do need you to know is that we only have one hop pass. Okay, so don't run two, don't run three, only run one. The purpose of the hop pass is to simply protect our root. If we don't protect our root, some bad things are going to happen to it. And so, for example, looking at this here, we could get what's called suck back. So once you put that hop pass on there, it's going to put a nice thin protective layer over that root pass. And so any pass that you put in after that, we're going to be able to turn up the heat, so that way we could melt a 1/8 rod rather than just working with a 3/32. If you could imagine filling up that piece of bevel plate with a 3/32 rod all the way to the top, that's going to take some time. And so in order for us to switch over to a larger rod and finish this out a little bit quicker, that root pass needs to be protected a bit more. If you do, for example, if you finish your root pass and then start, you turn it up to quite a bit more amperes than what you were using, then you're going to get what's called suck back. So no matter how good your root pass came out, If you put too much heat on top of that root pass, this is what you're gonna get. Suck back, or in other words, a concave looking root. So you could see how it kind of sank down in there. And so this was the root pass before. Notice how, again, it sinks in. Same thing here. And so you have to be really, really careful when you're doing your fillers and your hot pass, because if you're not, you're going to damage that root. And once you get to this point, the only way to fix this is to simply grind everything off, take the pieces of bevel plate apart, regrind them, clean it, and then start from scratch. And so you definitely don't want this to happen. Once we finish the hot pass, we're going to start our very first filler. And so notice on your control box, you do start to pick up the amperage here. Again, this shows 120 amps. So if you're in room 112, just take half of this, which is about 60 amps, and that's what you're going to be running at. This temperature, or this control box setting, is for room 111. So we're switching back over to a 1/8 filler rod, and you're basically going to keep running fillers over and over and over again until you get to the very top of that bevel plate. So this would be an example of a bevel plate as it's being filled up. Notice how we're doing a good job staying inside the bevel. We're not exiting outside that edge. As you recall, and initially when we were cleaning up these pieces of bevel plate, I asked you not to damage this edge. The reason we want to keep that intact is because by the time we finish our last filler and we start our cap, we want to be able to see that edge, so that way we still know exactly where we have to go, and our last pass doesn't end up looking like a snake or inconsistent. And so you're going to keep filling up that bevel plate until you're at least about a 30-second above flush. Okay, so meaning that the center part here, your highest point, is going to be a little bit over flush, but you don't want to be going over the edge. Your fillers always stay inside of your groove. They never overflow out into the sides of the bevel. When you do your very first filler, I want you to start on the lower part of the range. For example, 25. If you start at 35 right off the back, remember, we don't want to apply a whole lot of heat so close to that root pass, or else we're going to get sucked back. And so start on the lower part for maybe your first pass, perhaps maybe even your second pass. And after that, you should be able to turn it up to 35 or even hotter if you do tend to be a little bit of a faster welder. So the whole point is to just not apply a whole lot of heat early on, so that way we don't damage that root. So once you finish your very last filler, then you're going to start your cap. Notice that your temperature does increase. You're still using a 1/8. And just like our root pass, you want to keep your cap under 1/8 of an inch. So grab that 1/8 rod and kind of measure it. However, you're going to find that it's very, very hard for you to even exceed a 1/8 reinforcement on your cap, because with this process we don't have a whole lot of deposition rate, and so it's going to be hard for you to be over an eighth. And in fact, I don't remember the last time a student turned in a piece of plate to me that was over an eighth. One thing to remember is that when it comes to 1G, 2, 3G, 4G, it's only going to be a 1-bead cap. The only position that's going to require a 2-bead cap is the 2G position. And when you get to it, I'll cover it in a lot more detail. But for now, I want you guys to really focus on the 1G position and just kind of getting started with it. So don't worry about 2G for now. However, I still want you to write this down, so that way you do have that information once you do get to it. Now, let's tackle some common issues. So I mentioned earlier that 2G does require a 2-bead cap, and some of the common problems that you're going to encounter when it comes to bevel plate will be on that 2G position, because that 2G position does tend to be the hardest position that you will do in this class, even more so than overhead. And so when we're talking about a 2-bead cap, this is what we're talking about here. Notice how there's 2 beads stacked on top of each other. When you do 2G, you always do the bottom bead first and then do the top one. So as far as what a 2 bead is, that's really the only thing that I want you to know for now. Always do the bottom bead first and then do the top one. So let's talk about some common discontinuities here. So undercut. Undercut, it will typically happen because of these reasons here. You don't want to be long arcing. You don't want to be welding too hot either. Remember, I gave you a range. Yes, but that doesn't mean you always have to be welding within that range. If you notice that your piece of plate gets a bit on the hot side, then lower it down. That's not a problem. Also, keep your tungsten away from the edges. And perhaps you could try opening up your bead pattern a little bit more. If you open up your bead pattern more, then that means you're not going to be staying in the same area for long periods of time. And so you're going to be putting in a lot of heat if you do that. And so open up your bead pattern. It'll allow your plate to cool down just a little bit more. And undercut, if you don't know what that looks like, it looks just like this. It's almost like a notch that's cut in on the side of our plates here. That's different from incomplete fusion or underfill. So if we're looking at this cap, this 2 bead cap, notice how, yes, we do have undercut here. However, we have underfill over here, or incomplete fusion, same thing. Notice how we're not actually going over the edge. So remember, the whole purpose of the cap is to actually go over that edge as we're welding. Also, watch out for any trash buildup. Starting from your root pass, you have to make sure you use your wire brush. So anytime you stop, excuse me. So anytime you stop, you have to make sure you grab that wire brush, clean up your weld as best as you can. I can't stress that enough, because if you don't do that, even though to our eyes, it might look clean, but as you start building up all this trash, by the time you get to your cap, it'll look like this. And we know that TIG isn't supposed to be this dirty. It's not a dirty process. And so you'll have small little buildups of trash all along your cap. And so again, keep your tungsten sharp. Always make sure that you're using that wire brush as well. Also, anytime you stick with your tungsten, make sure that you keep that sharp. Every time you stick and you just pull back up and then restart again, you're going to be carrying a lot of that trash with you from when you did stick. Make sure that you're clipping your rods as well. If you find it really inconvenient to go out to use the wire cutters that we have there in the lab, buy your own set. That way you could just clip your rods inside of your booth and you won't run into that problem as well. If you have incomplete fusion, typically that's either because you're running too cold or because you're just not tying into those walls. So perhaps try going a little bit wider up against those walls, and that's going to help you out quite a bit. And even if you are welding at low amperage, you could still make it work. However, you want to keep yourself from advancing forward too quickly, because remember, at the end, it's all about heat input. And so even if you have low amperage, if you're staying in the same spot for long periods of time, it's eventually going to heat up to the temperature that we want it to. And so keep that in the back of your head as you are making those welds. If we look at this weld, clearly we could see that it's a little on the cold side. So whoever welded this, perhaps maybe they went a little bit too fast, or they're just using a very, very low amperage. This is more or less a summary of what we talked about. All of these notes you should have already. However, I did make this slide just so that you could have a slide to look at, maybe something to print out if you wanted to. So that way you have basically all the information that you need in one page. And so I look forward to kind of helping you guys with this. If you do have problems, always know that I'll be here available to help you out. However, that's all I have for you today. Good luck, and don't forget to take the quiz over this lecture as well.